So before we start, let's talk about what we just learned in the video. Why is it called Pythagorean theorem? Do y'all remember? The man who figured it out was named Pythagoras, and he lived in Greece. Okay, so they had weird names. Okay, so he figured it out, and what he was dealing with is he was playing with right triangles, and he realized that when you have a right triangle, there's these imaginary squares attached to each side. And he kept playing with it to see if it happened every single time, and it did. And so he came up with a theorem, which is something that you prove to be true. So that's the word theorem, something proven to be true. When you go to geometry next year, you're going to learn a whole lot of theorems, which is something these mathematicians prove to be true. And so a lot of times what geometry is proving something to be true. So it's like, how would you prove Pythagorean theorem true? You would take a whole bunch of right triangles and see if it works on every single one. And so that's what Mr. Pythagoras did, is he took a whole bunch of right triangles and he was like, wow, look, this is always true. The area of the two smaller squares will always add up to equal the area of the bigger square if it's a right triangle. Make sense? Okay, so let's start at the top. It says in a right triangle, the two sides that form the right angle are called the legs. So if it's touching the right angle, it is a leg. The side across from the right angle is called the hypotenuse. I have no idea why he named it that. I'm sure it was a normal word back then. Okay, so Pythagorean theorem, the formula is, and we don't write capital letters, we write lowercase. It is a squared plus b squared equals c squared. And when I write a squared, I'm actually talking about the area of the square attached to side A. When I write side B squared, I'm talking about what? The area of the square attached to side B. And when I say c squared, I'm talking about the area of the square attached to side C. Even if you can't see the square, it's like imaginarily attached. Make sense? All right, so what you learned in the video is the hypotenuse has to be side C. No matter what, C is always across from the right angle. And then the legs are side A and B, and it doesn't matter which way you label them. So you could call this A or this A. It does not matter. So it doesn't matter what you do. Make sense? Now, there's two reasons we use Pythagorean theorem. The first one he talked about in the video, to solve for a missing side. The second way you can use it is to prove if a right triangle is a right triangle. So just because it looks like a right triangle, you can't assume it is, okay? So right here, you know this is a right triangle because they put this little angle right here. Does that make sense? But if they hadn't put that angle there, you could prove that this is a right triangle, because if it is, then Pythagorean theorem has to be true. Meaning, the area of this square plus the area of this square has to equal the area of that square. If it doesn't, then it's not a right triangle. Okay, so let's pretend we don't see all these numbers. I would say is 3 squared plus 4 squared equal to 5 squared. If it is, then it is a right triangle. Well, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Is 9 plus 16 equal to 25? Yes, 25 equals 25. So yes, this is a right, I can't spell, triangle. So if they give you all three sides, they're just going to ask you, is it a true right triangle or not? And you could use this theorem to say yes it is or no it's not. Okay? All right, turn to the back. Now we're going to learn how to solve for a missing side of a right triangle. So the two examples at the top are solving for what? C, the hypotenuse. So the first thing I would do is label side C. And then I would write the formula. And then pick which one do y'all want to be the A and the B. It doesn't matter. 6 is A, 8 is B. It doesn't matter, though, if we do it the same, because you're going to get the same answer. All right, so I would write A squared plus B squared equals C squared. And then fill in what you know. I know that A is 6, so 6 squared plus, I know that B is 8, so 8 squared equals C squared. 6 squared is 36 plus 8 squared is 64 equals C squared. I would add this together, and 36 plus 64 is 100. Now, have I solved for side C, or is this the area of the square attached to C? How do you know that? Because it says C squared. Does that make sense? Yes or no? So what I'm looking for is, this is actually, and you don't have to write this down, this is actually saying what times itself is 100. What if you didn't know that? What would you do? You would square root it. So your last step is to say, hey, if I square root 100, that will give me side C. And the square root of 100 is 10. And this is actually a famous right triangle. Remember how I told y'all 3, 4, 5? 6, 8, 10 is a famous right triangle as well. So some things you can just memorize those. I'm going to let y'all try this one on your own. There is a right angle right here. They just didn't draw it for you. So y'all go ahead and solve this and set it up, and let's see how you do. Does it not have batteries? You can just grab some underneath. If you choose a different A and B as me, it does not matter. You will get the same answer. Okay, when you finish, see if you got it right. How did we do? Could you skip some steps since you have a calculator? Could you put this in your calculator all at once and like type in 14 squared plus 48 squared and then just square root it? Yes. So I'm not making y'all write out all the steps. I just want to show them to you so everybody understands why I'm doing what I'm doing. But you could absolutely put this all in your calculator at once. Make sense? All right, go to the bottom. So what do y'all think is going to be different if we're given C? I'm going to end up subtracting instead of adding. So let's look at it. So here's my right angle. This is side C. So we'll call X the A and 15 the B. So I have A squared plus B squared equals C squared. So I'm going to plug in what I know. So A squared is going to stay A squared plus 15 squared equals 21 squared. So if this was a normal equation, I would need to isolate the variable and move this to the right side, and I would move it by subtraction. Now, you could go ahead and square those, or you could put them in your calculator all in one step, and I could say, hey, I need to subtract 15 squared from both sides, and I would get A squared equals 21 squared minus 15 squared is 216. Now, is this my answer for side A, or is this the area of the square attached to A? So my last step is to square root it. So the A is equal to the square root of 216. which is 14.69. If we round, let's round to the hundredths place. So this is the hundredths place. So that 6 is going to make the 9 go up to a 10, and so it's going to be 14.70. All right, y'all try the last one on your own. When you're finished, check your answer with mine. Everybody got it right? Are there any questions? Now, could you apply this if I gave you a problem and it took it to the next step? For example, what if there was a picture that looked like this? And it told you this was, I'm going to make this up, 27, and it told you this was 70, and it told you this was 10, and it wanted the height from here to here. Would you be able to figure this out?
Yeah.
So tell me what you're thinking. What do you need to get this entire height?
You need to add the top thing plus the
So I basically could just take this out at first, right? And this is a right triangle. I would be solving for side A or B. So once I solve for this, then I would just take it and add the 10 in to go all the way to the top. Does that make sense? Okay, so sometimes you're going to have to really apply the theorem into a real world situation. Make sense? Okay.